Welcome, I'm Bill Wake. We're here working on a programming language called 10th. We're working on a compiler slash interpreter for it. And up till now, we've been working on various primary operations. I think the last of those is a few more stack operations. Then we'll do control structures if and while. And if we get far enough, well, probably tomorrow. We'll see. We also want to tackle variables, arrays, and strings. So I have some ideas for how to do that, but I haven't fully worked it out. But we'll go with what we got if we get there. All right. Now we left off. Our code runs, all our tests pass, and in particular, the stack tests, CAB passes, puts third item on top. So ABC are sort of conventional names for the top of the stack, the second and the third. And so the CAB function takes the third element and moves it to the first. So the stack now looks like CAB and whatever else it had in it. And we ran the test and it was fine. But let's run it in the repl. If you have 3 on the stack first, then 2, then 1, so 1's on the top. All right. And I'll just print and we'll see the 1's on the top. Now, if we do CAB, we expect to get 3, 1, 2. Okay, so CAB, and now what's on top? Well, it's the 2. And if we, I forget what we said, drop? No. Pop. Yeah, and dot. And now 3's on the stack. So it looks like all it did was delete the 1. And that's exactly what it's doing at the repl, but the test was fine. So that makes me want to go right away to main, if I can find it. Yeah, and sure enough, oh, well, swap and pop are wrong. Okay, let's try swap. 2, 1, swap dot. Oh, no, that's, oh, okay. And if I pop it, dot 0. So it also just did a pop. Okay, so, and this is not anything, our test was a test of pop, but you have to hook it up to the right dictionary word, like, okay. And let's make repl. So we should have 3 at the top. And if we drop that, pop that and look, 3, 1. Yeah, that's right. So that's A. And then pop and look at the bottom. It's 2 and pop one more time. We're back to where we started. Okay, now let's just do 2, 1, swap, print. We should get a 2. Okay, and if we pop it and print, get a 1, pop that, print, we're back to the bottom of the stack. Okay. One of these days we're going to put in something to detect underflow on the stack, but we're not doing it now. All right, and I did one more thing offline. Let's see if I can find it. Control. I decided I've been using underscore for like these internal words that might get called by things and stuff like that. And jump had it, and jump if false, and push. I don't know if there are any others, but those 3 stuck out to me. So I took a little time and renamed stuff. That's why there's so many changes on this check-in. And I did peek and see that main was wrong. I didn't notice it for swap, just for CAB. Okay, so let's do ACP. Fix swap and cab in repl. Rename jump if false, and push to lose their leading underscore. Yeah, cab is a rotate. But you sort of have, well, you can imagine other rotations. Is that useful? Well, I guess you could imagine a BCA function that rotated something the other way, or you know, you might have them. I like the name CAB because it just tells me like, okay, it's not ABC anymore, it's CAB. Okay. Apparently I don't like pop well enough because I keep typing drop for it. Okay, so I think what we're working on though, well, let's go back to, whoops. Doo-doo. Okay, repl called wrong function. All right, and this is the 33rd episode. Oh, 32nd. Okay, and then yeah, so CBA is another variation. Let's do that one. And this should be very similar, right? Although I keep finding more stuff I want to do, so I don't know. All right, so cab puts third item on top, yeah. And this is like BCA puts first item below second two, something like that. And we're calling BCA. Is that what I said to do? CBA. Okay. Puts first three items. Well, let's just say reverses order of first three items. Okay. And I'm getting I feel like I'm making this harder. If I just made this 1, 2, 3, I would know what was going on. Which seems like a good thing. Okay, CBA. Now we're testing that the stack is still 24 bytes out. That's fine. But the first we should see is 3, 2, 1. All right. And we'll need a function CBA defined in our stack. That's an existing test. Ooh. Jimmy BC stack.o.post. Stack.o. 143. Oh. Well, I meant to put a colon, is what I meant. All right. And we forgot to call our test. All right. Let's get the name right. We want to see that failure. Well, my test is bad. Okay. Huh. Did I put them in the order? Oh, no, I want to push 3 first. then 2, then 1. So 1's on top. That's more like it. Okay, so the middle one's the right one, but the first and third are wrong because they should be switched. Okay, very easy. Okay, and then this, we'll just make a slight variation. We still want to pop the first 3 things. But you know what else I'm going to do? Just to keep my head straight here. I mix up those 0, 1s, and 2s too much. So we want x3 first, then x2, then x1. All right. Make. Okay. And let's see if we can get our main correct. CBA, get CBA. And we'll make repl. All right, so 3, 2, 1, CBA, the top should be 1. We'll see if we can get the whole thing right. So CBA 1, pop that. Top should be 2. Pop that. Top should be 3. And we'll pop. That'll put us back. So we should see 3, 2, 1. Yay. All right. And I'd like to do refactoring because I think this 1, 2, 3 approach is better. You get like 1 through 7 or 1 through 8 or something. X0 through X7, I think, are temporaries. You can use how you want. So the name doesn't matter. So each one's going to increment by 1 here. X1, X2, X3. 1 goes to 2. 0 goes to 1. Goes to 3. X1, X2, X1, X2. X0, fine. It's not used, so we don't care. Count data. Yeah, I don't really know if I like that function. I think it helps a little here too. Push 1. Yeah, well, no harm. No, I want. All right, let's make. Okay, all those stack ones still green. We renamed register usage for stack ops to use X1, X2, X3 for most operations. Good. Okay, so that was CBA. And now BAB. Copy second item to top. Okay, so I don't need this one. I'm just going to have 2 and 1. Call BAB. The stack should be 16 because we only have 2 things in it. We expect, well, when you look at the first one, we expect a 2, then a 1, and then a 2. All right. So push a 2, push a 1, and then we expect 2, 1, 2 on the stack. And this is calling BAB. Let's make it, put this in the test. Should fail. All right, so there we're grabbing garbage out of the stack. But we're looking for the first one. Oh, now this is interesting. I guess we pushed, well, that assertion's wrong. The one that passed shouldn't have, because there are 3 things on the stack now. So let's get back to that situation. All right. This will be better. Everything will be wrong. All right. Yes. Okay. Let's go to BAB. Well, this time we just needed data pop AB. All right. A is X1, B is X2, and a data push ABC X2, X1, X2. You could probably do it well, this will work. Yeah, BAB is duplicate the second item. We could make an ABAA alias for dupe. Right. Yeah, dupe is basically, I mean, I would call it AA in that scheme. So I'm only basically ABC are the top of the stack, top 3 items on the stack, but only mention the ones you actually use. So in this one, we don't worry about C when we're doing BAB. And so I would say by that scheme, AA would be dupe, but I'm just going to leave it dupe. Yeah, consistency is not a factor here, I guess. All right, let's fix this and make. Now this should all pass. Good. Okay. The only qualm I have is like we're really popping this bottom X2. We could just like peek on it and then push one thing. I just don't think BAB is going to be a performance nightmare for anybody. It's just not that commonly used, I don't think. Okay, but it would be. All right, the other thing that's on my mind is the stack error thing. I think what we should do, I think maybe users should do data pop A, and then data pop is sort of an implementation detail, and then somebody should be checking the end of stack at the end of data pop A or AB or ABC. We'll save that, but let me make sure it's on our to-do list. All right. I guess I'll mention it after here. So this is check for data stack underflow. And another thing is maybe debugging tools for 10th users. Okay, so one thing would be like a flag that says print the stack, data stack before every instruction. Every instruction. And another might be, well, I don't know. Maybe you could put a flag that says don't do any debug stuff until you execute this statement or something. I don't know. But we can come up with stuff. I have a whole book somewhere. I don't know where. Oh, I have a book on how debuggers work. So if we need to run out of ideas, we could go to that. But normally you want some sort of dump facility, some sort of step facility, and I don't know, then everything else is kind of added on top of that. Yeah, dump word. It would be nice to dump our secondaries. That would be helpful to us as developers, which means I probably should have done it way early, but we had some hard work manually verifying the contents of those the other day when we were trying to figure out why repeat until was messing up, and I was looking in the wrong place. But it was relatively hard to decode those things because they contain pointers to stuff and things like that. So, but something to dump, like we're going to have variables at some point, dump those, dump arrays, that would, um, that would be helpful to a programmer in our language. I could definitely see a step thing, but yeah, we'll have to see. All right. I don't want to spend a ton of time writing tools to go with this because I mean, this really is more of an experiment for me. I'm not going to write 10th programs for a few months or a few years or anything like that. I'm doing this to prove to myself I understand that secondary structure implementation and, kind of seeing all the consequences of some of these things we're doing. Just seems that's what I want to get out of this. So I do want us to write a real application that's kind of a medium-sized thing, or medium to small, but a real one, a small game, a calculator, something on that order. And if we need tools to do that, we'll create some tools along the way. I wonder if there are tools we can create at the source level that might do it. Yeah, getting to do TDD in assembler is definitely one of the things I wanted to do with this. It's been interesting to me. I mean, it's kind of like, well, let me do this. Let's see, where did I leave that? Over here. Obj dump. Let's dump repl.out because I think our actual code is not that big. Repl.out. Okay. Minus D. Okay, so I want to take our maximum address is 103 FA0, which everybody starts with 1. So I think 3 FA0. And then let's see where our first programming address. Now this is our initialize because it's all those dictionary definitions. I think we can do those in a better way. Okay, but we're still out to the back. Is it going to be 3,000? No. Do something. Okay, well, it's bigger than I thought. Okay. First one is 2C58. Okay. All right, and I lost my calculator. All right. Okay, so let's clear this. 3FA0 minus 2C58. Okay, OX1348. Okay, that tells you what we've done. Of actual code, we've written less than 5,000 bytes so far. So, you take your multi-megabyte, I don't know, Xcode, who knows what that is? Could be a gigabyte for all I know. I don't think it's a terabyte yet. But basically, we've written about 5,000 words of assembly code. Well, which really, because that's bytes, our instructions are 32 bits. So let's divide that by 4. Oh, 1, 2, 3, 4. Nice number. Okay. That's how many instructions we've got right now. All right. So it's not a big application. So 5,000 bytes to run this thing. I mean, that's not as good as they did on the old Commodore 64 and stuff, but they had 8-byte instructions. They could squeeze some stuff in. So this is, I mean, it's been, I don't know, this is 32, right? So 32, well, 40 hours would be a week. So times 2.5, because we do 2.5-hour sessions. So, we're 2 or 3 weeks into the project, if you want to look at it that way. So that's, Well, that's a lot of time for 1,200 words of instructions, but that's the way it goes. Memory allocation takes up space. Yeah, the setup is the killer from um, the point of view of the routines we actually wrote. And if our start routine has a bunch of macros for all those dictionary header things. Um, yeah, we definitely, I think we've now proven that we can put those in the data segment if we can structure them right. And I think we'll do that and cut the code segment down even more. Um, but it's not, I mean, this is a fairly high bit of functionality for what we're paying in terms of assembly instructions. So yeah, kind of cool. All right, let's see where we are. We just did BAB. Let's make repl. Oh, did we put it in main? I don't think we did. Nope. Make repl 2 1 BAB print pop print should be 2 1. Okay. Yeah. All right. So I think that's it for stack ops, at least for now. We may think of other stuff, but we'll save that. All right. So I want to go into the control statements. I think I've resolved whatever was TBD about them. Let's go back here. Okay, stack operations if and while. So I've changed this a slight bit, but basically the code on the left is the sort of generated instructions in our secondary list. So whatever code for A comes out, that's on the person writing it. It's not that we generate whatever we generate for that. We want to do a jump if false to the end. Okay, so this is just if. I think, did I? No? Okay. I didn't really do the else case. Oh, it's on the right. Okay. So if you just have if and then the end, I'm using phi because that's an old, came from Algol kind of abbreviation. So it's if backwards. All right. But it had to be something. And I thought, well, let's tip our hat to Algol. Okay. So if the condition is false, we're going to jump to the end and not execute the body. Okay. And then we have code inside if. That's whatever the ... generates. And at the end, we have the code after the if. So you get a nice, that's about what you'd expect. If the condition's false, don't do the if. All right, now the if then else case on the right, you jump if false. Well, you jump to else label. You don't jump to the end. Instead, you then execute the code inside the if, and then you jump basically around the false code, the else code. And that's jumping to the end. And then you put out the else label, and then the code for the else is the target for that jump in the first couple of lines. And then they both converge at the end for the code after the if statement. So the structure of the middle part is what is the actions we're going to do to make this happen. And we have to track it two ways. What if there's only if and phi, or what if there's if else phi? So we want to make if and phi apply regardless of whether we had else or not. All right, so both of them start out the same. They generate a jump if false, and we're going to push an address on the control stack and write the constant -1 to represent a placeholder for that either end or else label that's coming in. Then the code inside if is generated by other stuff. All right, if we have no else, we jump down to the bottom. We pop the control stack that gives us a patch value, or the address to patch. And then we take the current code address, which is the label for end, and put that back at the third line on the left, the end. Okay, that's where that gets put in. All right, and that's the code we want for that one. Now let's take the if-else case. As before, we generate jump if false and push the address on the control stack. But when we come into the else, we start by generating a jump, and then we pop the control stack to get the label to patch out. And then we push the code address to the control stack. So we're putting the address we're pushing is that middle line where it says arrow end. The address of that is where the next patch should be. Okay, and we'll generate a -1 there because we don't have that value ready until we get to the end. All right, but then we also patch the current code address, which is after that -1. It's whatever the body of the else is going to be, is going to go to the patch location where it says else label, and that's what we want. After the jump is the else label and the code for the else. And then as before, we pop the stack, and now we're going to patch that end spot in the middle with the address of the code after the end. So the jump, if we terminate, if we get to the end of the if statement, should jump to the code at the end. All right, so both ways, both those seem to do their job. And then let me go, let's look at the next one just because it's kind of similar. The code on the left, again, is the code we want to generate. So start, and then the expression is some other code that gets there. And then the start of the do, because we only want to do this if the value is true, then we're going to jump if it's false. All right, so the while, it puts the address of the start on there so we can come back around to the top of the loop and execute the expression code again. The do generates the jump if false, saves the address, and then generates a -1. So the value on the control stack is the address of arrow end loop. Then we do wherever the body is, and then the odd generates a jump. So the end of a while loop just jumps back to the top, and we're going to take two values off the stack because we got to patch two places. We got to patch one place. We'll generate start. So we pop both of those off because we have the start address on the bottom and then the jump if false on the top. We're going to put the start in, generate that right after that jump. Okay, so it's not really backpatched because it's already, it hasn't really been written yet. And then we go to the other one and patch that jump if false so that end loop points to the address we said. Now, is that right? Yeah, that's the next instruction will be the code after the loop gets put into where it says arrow end loop. Okay, and so I think this is, notice these schemes only need jump and jump if false. So they're similar in that sense. I think the version I had of this before, the expression, you had to duplicate it at the end of the body and stuff like that. This I think is better that you get that expression in there for evaluation. So cool. And let's keep this one around because it's the one we're going to do first. Now, fees less to type. And also I felt bad saying end if and then do was done. It's like those don't line up. Repeat until, I think that's just too much of a common structure to worry about. But yeah, who knows how much time we'll save ourselves not having to type, the extra 3 letters to get our end ifs. Or 2 letters for if odd instead of done, it's critical. Okay. Now let's go back and look at our control and our control tests. All right. So I think the test is maybe the more interesting one. We'll get down towards the bottom. Okay, this was our nested repeat until. That test was actually not needed. I mean, we didn't do anything. We didn't change anything to get it. Haha. No LF. Yeah, well, we'll see if we need it. We know just the people to implement it if it turns out that our code really wants a bunch of else ifs. Okay. So, actually, like this nested repeat, the problem was not in our nested repeat. It was in our 10th language code that didn't nest things properly. So, or that computed down to zero and then did a repeat until on that, which is going to get worse and worse. So, um, we got a bunch of negatives. But I think this test, well, the thing that's good in this, I think it was smart of us to put fake bodies in so we could verify where the body showed up and all that. In the repeat until, we didn't bother with that. We just did only the instructions for repeat and until, and knowing what they should do was fine. But there's some subtlety in this one. If you said go back to this line instead of this line, it would it would make a difference. And the other one you probably couldn't tell so much. So I think what we'll do is I don't need to do the nested test, but I do want to um, put bodies in, fake body code that we can assert on. Okay, and I'm just going to copy this. Maybe foolish, but there's a lot of similarity. Okay, so this one, let's just test if if phi generates right code. Okay, and so again, there's sort of multiple levels. You could, well, what we're doing is saying we're going to test the compiler's ability to generate the secondary code we expect. We are not doing, we could also then take that secondary code and write a sort of language level test that made sure that, well, no, an interpreter level test that made sure that that code executed the way we expected. And then we could go back a third way, would be to write the language level code that uses if and phi, and again make sure the code does what it expects. But we're kind of working in the middle here. I think I don't think that. Well, I worked in a digital deck back in the old days there, and as a compiler developer. So, and I'll say that basically the stuff we were doing would be checking that intermediate form that you generate. It's kind of the job of further down stages to make sure that the intermediate form gets translated right from there. But we would check this. And we did unit testing, but we certainly didn't do TDD. And a lot of outside testing too. I was pretty impressed when I went there to see how much, outside testing was done. One of my jobs was to carry around, like, when you wanted to release things, you wanted to make sure it worked for every processor you supported. So they had a group of them at our, in our lab, but there were, I don't know, 10 more models that you might have to test for. So we had what in those days was, I don't remember how much it held, but not a lot. It was a disk pack about, maybe 10 inches across or something, and about 3 inches thick, and it had three platters. And you put it into this washing machine, small washing machine, but still washing machine sized disk drive thing. And you would take that disk from computer to computer and negotiate with other groups like, hey, can I run my unit or my system test suite on your computer before we release, your VAX 11785 or whatever the heck things they had back then. But it's kind of the same thing that goes on now. You see people that are, for web browsing that take, the same code and run it on 8 or 10 different browsers and try and verify that it still works on all those. Some things don't change. All right. So let's see. We have a secondary space, and well, we need test secondary area. I'm gonna 16 bytes. That might be enough. That's probably enough. Okay. Um, okay. So we're setting up. We're using x28 as a temp, so we'll store that in our right after our procedure prologue. Okay, so we'll load the address space, init the control stack. That's good. Move x28 to hold the control stack. Okay, so x28 is going to let us keep that reference around. All right, so the first thing we'll do is put a 1 in there. So this is the code before the if, and this stores it. I feel like maybe that should just be a macro as well. Let's do that. We'll implement the macro for now, and then we'll come back and use it more broadly. Store secondary, and it's got a register. And all it's going to do is this. Okay, I think that's in our spirit. And we'll go back eventually. Okay, we're gonna branch to, I don't know if I can use word if. Maybe. Okay, and then we'll do the if. We'll do the to. It's not nested, really. I mean, it's nested in there, but it's not like our old one. And then let's do phi. Okay, so it's x number 1 if number 2 is the interior body, and then phi. Okay, and keeping track of this, right? So space plus 0, the body. Well, this is 0 plus 8 plus 16 plus 24. Okay, so this we expect to be space plus 24. And again, we'll do a store sec x0. Store sec for 2. Yep. All right. So what are we expecting? Well, x0 is secondary test area. x0 is 24. Jump if false word address. Okay, so we're saying 24. Well, let's figure out where this should really be. I mean, we're going to see, well, we're expecting 0 to contain a 1, this to contain jump if false, this to contain that. Okay, maybe that's the, I almost think we're better off. Okay, this is not jump if false, right? Let's x0 plus, I don't know, I'm just going to do it like this. X1 equals pound 1. Okay, so we're gonna go through all these. So this is the 1 plus 8 should be jump if false. Yeah, so this one is actually closer to what we're after next. Okay, now they vary. So I'd almost like to get that load test secondary area too. Okay, let's, well, now I have this printed. X28 is reserved, so is X27. Let's store X27 as well. Now this is getting ugly. I don't know how much to fight it. Okay, but anyway, word 8. Maybe I'll just do it and then simplify it. Okay, so the first word should be a 1. The second word should be our jump if false. The third is kind of like this one, I think. Oops. Okay, so the third word should be the address. So that should be test secondary area plus, well, not 8, because that jump if false is jumping down to the end. So we're going to have to work our way up to it. Okay, but then the next one should be like the first one. Okay, I'm going to put a TBD there for the minute. Okay, this one's going to verify cell 24. It should be R2. And then we're up to cell 32. All right, so this is 1, jump, address, 2. And then this should be the target of this. So this is 0, 8, 16, 24. 32 should be the target. Okay, so the address here should be test secondary plus 32. Okay. And my, this would be easy to get wrong, wouldn't it? All right, and then this one, 32, well, we don't actually have anything that comes after the if statement here. It's just the address 32 that counts. So I believe we don't need any assertions after that. 32. Okay, let me, well, I'll take those out and then we'll put them back if we have to. But so we're saying it should be 1, jump if false, start plus 32, followed by the 2, and then we're at the end, so there should not be any more code there. It'll be the N2D when we generate our real code if we did that, or whatever statement came next. Okay, but we always have an N2D, so we know there will be code there to jump to. All right, I think that's right. And then control stack, we saved X28 to make sure control stack is back where it should be. Okay. All right, and then he references if and phi. And as usual, just make them empty. All right, I think that should run and fail. Compile. There we go. All right, so the first thing looked okay. I guess that was the first cell containing the 1, pound 1. All right, the rest of it is bad. The stack is weird. Okay. Everything's off. Good. But the control stack did get popped. Okay. Or, well, it didn't increase, and it's got the same size it always had. We didn't actually push anything on there, so I don't think it's really going to increase. All right. So, well, as always, that's a good sign. It failed how I wanted it to. Should 36 be end to D? Well, no, because the if statement doesn't generate that. Sorry, the end, the fee does not generate the end to D. That's generated by whatever comes at. I mean, if we had if blah 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 fee semicolon, the semicolon would put the end to D on there, so the address would be right for the jump, but this test won't put any code in there because it's outside. Yeah, 40. So we'll go down there again. Oh, I think 32. So we're jumping to address secondary or plus 32. That'll end up with that. Would you feel like it made more sense to have that code in there so we can target it? Or, I mean, I don't think it changes anything. We're writing to wherever it's going to put code next. So I think we're okay without it. But clearly we're not doing a lot here. Okay, so we did store our two secondaries. Now, why did this one not pass? Oh, because it's in the wrong place. Okay. All right. So I think this should be relatively straightforward. The if will generate the jump if false and push the code address to the stack and generate -1. Okay, so well, it's kind of like this. It generates the load address and it stores that, which we'll take care of soon. Okay. And it pushes a -1. I don't know. We did that somewhere. Oh, repeat until doesn't need to. Jump if false. Okay. Well, then we're going to store x0. Well, let's store. Yeah, I think that's fine. X0. We'll generate a 0 instead of a -1. There's no big difference. No, let's do the -1. X0 gets -1 and store X0 to secondary space with an offset of 8. Okay, but we have to catch it beforehand. So we want to capture the code address before we add that -1 to the code, because secondary space after the first instruction is where we want to put it. So we'll capture it here. We'll do a control push the secondary space. And I think we did that before, right? Yeah. Okay. So let's see. If handles beginning of if statement, generate jump if false, store address on control stack. Okay, I think that's okay. I'll take that argument. All right, so we have to generate then. We'll do this, but with a 3 after it. Okay, and then in our code, the fee doesn't take any space, right? It just pop stuff and write stuff back, but it doesn't do anything to the current thing. So the offset after the fee is really just the next word. Okay. And then let's make an assertion about that. Let x0 plus 32. Okay. And, well, I think we'll get a different set of things failing because we push stuff on the stack now and it's different. So that part's going to, that last one fails because the control stack isn't empty. Okay, and this one fails because we haven't generated the right patch address. Okay, but I think we're kind of good though. That one should have failed. Oh no, I guess we got the right stuff in the right place, but the address isn't backpatched because we didn't do the fee yet. All right, and then fee, pop the control stack, put the current address at the stack location. Okay, so that's almost this. Matter of fact, pop it into x0, store x0 secondary space plus 8. No, that's not really the right place. Store x0. It's really, The x0 is the address we want to write to. I think it's more like the other way around. Okay, is this going to make sense? I think you're not checking the if the answer. What if you skip the answer? Okay. So pop the address. Fee handles end of if statement. Pop address from control stack. Backpatch current sec space there. All right. I feel like we're close. Hopefully that's all it takes. Where's compile? Control. Okay, so theoretically, let's run our repl. And this is only, well, okay, we haven't implemented it in the repl. This is like repeat until, it's going to be a meta, so we're going to have to edit main a little more than we usually do. Okay, so here's repeat until. I'll just stick these in with this control statements. If fee is to fee. Okay, because it's really a compiler thing, we're not supporting command line. I mean, we'd let you do some stuff automatically or some stuff in the repl at the command line automatically executing. Control statements are not one of them. We don't really warn you, which is, again, the sort of thing that I would fix up if we were doing it for other people. I'll just shoot myself in the foot a few times first, but anyway. All right, but we should be able to compile it. Okay, so if we define, let's define foo. Let's put a non-zero value on the stack if, let's dupe it, if, and then print it and end semicolon. Okay, so push a true value on the stack, duplicate it, if will consume it, dot will print it, and then maybe we should do a little more just to make sure it's really gone. Let's print again. Okay, and so it should print a 0 for that second one because that's our kind of guard number on the stack. All right, compiled, and let's run it. 2, 2. Okay, so we consume it. If I pop again, let's look at there. Okay. Oh, so we left the duplicated value, well, the original 2, I guess you'd say. We printed that, and then we printed it again. If we had done it backwards or something, it would not. Okay, so let's do that. I can overwrite my definition, 0 dupe. If consumes the stack, we'll have to make sure of that. Yeah, that's a good thing to make sure of. I think this test will kind of reveal that. Okay, foo only prints the false. Oh, but I can't tell if my stack is bad. Okay, let's pop dot 2. Oh, that's the old one. Okay, pop dot 0. Okay, so I think that's back to an empty stack. This, yeah, there we go. Control stat pound sign tells us that. Kind of goofy, but that's what we have it for. All right, so I'm back to normal. Let's run foo again. Okay, so foo false duplicate, it should leave a 0 on the stack. Okay, because we didn't do any deleting. If should delete, but the dots do not. So if I pop, I should still get a 0 on the stack, but now I should have the other one. If I pop one more time, I should get the junky one that's totally out of range. No. I don't know. Oh, maybe we guarded ourselves. Yeah. Let's see. How can we tell if it consumed the stack? Okay. Foo to if dot fee dot semicolon. All right. So yeah, I think there probably is just reserve space or something. But this one, if the 2 is not consumed, so it should print the 2. No, it should print a 0 at that point if the 2 is consumed, right? So I believe this one will tell us if it's consumed or not. Okay, it is. So we got inside the if. What we printed is whatever happened to be on the stack first because 2 got consumed. Okay, so I'm kind of good here. Yeah, we can't tell that. Right. Oh, I know why we know it's consuming because it's running jump if false, and we've long proved that that's there. Yeah, let's see. Okay, so we got if done, I think here. We just verified that. So, all right, implement. Boy, that went fast. If. Okay. And yeah, let's go look at that stack. See what we had there. So that's the one I think we could, oh, no, that's not it. Stack count label, stack count suffix. Sorry. Okay, we put that in front. Yeah, we don't really control. Well, yeah, we're not printing hex, so let's find what's a I mean, I don't know. You can't do oops. No, we can't get zero. Um, what's P? Is there a, does that look like a word? Okay, we'll go to the mighty internet. Words spelled with numbers. Nope. I don't know what I want to get. Funny word spelled with number. That's, yeah. Well, I don't want the ones you have to hold upside down. Okay. Zeus is a logo. We want to find one that sounds like us. Yeah, a lol might. Lilies, yeah, that's kind of clever. Um, okay, yeah, let's do that because it's sort of associated with tombstones. We'll live with the fact that it's upside down. Um, okay. Now, when I first started, like, I think it was Pascal, one of the early languages I worked with. Um, when you had a null pointer exception, they would print what they called a tombstone. It was a little boxed thing that told you what you did wrong, and it's definitely a long tradition for that. Okay, so now this, we expect to see some junk um, before our at the start of our stack. So this should give us something junky. Okay, lilies. All right, if I do 1, 2, 3, pop, pop, dot, pop, dot. Yeah, we're back to that. Okay. Yeah. I think once you know it's supposed to be an upside down word, you can kind of get there. Just silliness. That's okay. um, but we do stuff with stacks. I'm gonna put it 4 times because like a CBA or something, something that pops 3 things would still at that point would be getting back into who knows whatever's in the previous file. Okay. Um, fine. All right. Make repl dot pop dot pop dot pop dot. Now it should be getting out pop dot. Okay. Yeah. Whatever random zero came in before it. Okay. It could be the secondary space might be just stuck in there before the stack, but um, put a marker word at bottom of stack. Lilies. Okay. Just one of those things to keep us on our toes a little bit, make it easier to see that the mistakes are there. Alrighty. Well, we've done if else. Okay. And I'm going to move this down a little because we could put a little marker in there, but we might still like to do that. Okay. I guess we're on to repeat until or while do. Oh, we didn't do else. Sorry. Let's do else. So we'll need a test for that one. Okay. I'll let them go. I think we'll before it matters again, we're probably going to rework our pop code to check for Stack Overflow in the first place, and so we should never see those. Should always just throw a message up there. But um, yeah, it's okay. All right. So if well, we got two, and then we're going to do BL else, and then x0 gets 3, which is somewhere plus something, and then store sec x0. Okay, so 1 if, 2 else, 3 phi, and then a 4 here. Okay. Now, I'm not calling this code, so I think there's no problem with it. Um, hmm. So maybe before we move on, I think I want to refactor a little bit here. Let's pull this up where we can use it in our code, and I think that's core defines. Oh no, is there another defines? It's not assembler macros. Well, that's kind of where we put it. Yeah, maybe that's as good a place as any. Okay. This is store register contents into next slot in secondary. All right. And get it out of here. Okay. And then let's use it where we can here. Store x0. So this is okay. And okay, we didn't need it there. Jump is not doing that. Okay. Yeah, I think we've made use of it there. Test should all pass. Oh. Control test still good. All right. And in control itself, now wait a minute here. Oh, that's the actual patch. Okay. But this is store sec x0. And so is this. No, wait a minute. Okay. Okay. Let's make this test fail. And I guess the other thing I kind of want to do, like these guys all look a lot alike, or a lot of them look a lot alike. This is sort of the same as offset 0, but we have a lot of assertions that are very similar. Okay. Where's else? All right. So else we'll initialize things. We're going to put a 1 in. Then we're going to do the if, which generates jump if false in the end. Okay. So this is byte 0, 8, 16, 24 is the front, right? And then, okay, so that's 24. Okay, so this should start the same. We're going to look at slot 0 should be our 1. Slot 2, or at byte 8, should be our jump. Slot 3 at 16 should be the patched value we're jumping to. That's going to change. That's going to be to the else label. Okay, 0, 8, 16, 24, 32 is the jump, 40, 48 is the else label. Here. Okay. And then we expect the 2 for the if clause. That's code inside the if. Then at 32, well, we really expect it's kind of this. Okay, after the code inside the if, we expect to see a jump. And I don't know where do we have a jump word address? We don't. Okay. And the reason is this word is not, it's not a word the user types. So if it were a user word, it would be in the dictionary already, but we're not putting jump in the dictionary. We're just using it internally for our control structures. Okay, so that's that. Okay, so this should not be jump, it should just be jump word address. Okay. And then the next cell, 40, should be a target of that, which is kind of like this. Okay, so a word 40. So the jump should go to the end. Okay, so if this is 40, this is 48, 56. Okay, so after the jump, we expect to see code for else, which is 3. This is now at 48. All right, so that's 3, and then we expect to see the 4. Yeah. At 56, we expect to see 4. And control stack should be restored. Okay. Let's call it. And this should fail. Well, not quite that way. I just think it makes more sense to put the word address first. Okay. All right. So first 2 words are right. So the first 2 words are the A and the jump if false. The else label is screwed up. Then we should have the 1. Okay, that's put in. Then a bunch of other stuff is messed up. Everything's messed up from there on down. Okay. So, whoops. Else, it generates the jump, and then it pops. Excuse me. All right. Else. Okay, that's sort of just like this. Except it's jump word address. All right, pop the control stack. Okay, so whatever the if pushed on there. All right, push the code address to the control stack. Okay, so that's control. Okay, now I gotta look at control push. I don't remember where that's defined. Must be an assembler macro. Right, store register. Control stack. Okay, it doesn't consume any, it doesn't mess up anybody else. Okay, so X0 is still valid here. Okay, so we push that secondary space. Now we generate a -1. Put the current address and then backpatch. Okay. We're still holding on to x0. Okay, what's the last step? Generate -1, and then patch. Put the current code address to the patch. Wait a minute, are we forgetting a step? Okay, we pop the thing else label. Push the code address to the control stack. Generate the -1. Put the current code address to the patch location. Okay, that's the x0. So we want to jump after the skipping jump, I guess. Okay. Sorry, make sure I'm doing this the right order. The current code address to the patch location. Which is kind of like this. So we want to store the current address to contents of x0. All right, the jump in front pushes itself back. Yeah, there's that little dance in the middle there. It's a little funny. So we generate the jump, and then we're going to pop the old patch location because we're going to put something else on top of the stack in its way, which is the target of the jump because we don't know where the end is going to be yet. So we're making room for that. We generate the -1 because we had to capture the address where the -1 was going to go. And that's the thing that should be on the stack. Okay. But we've still got x0 because we got to patch the first if, and we're going to store it to point to the body of the else. So store this at that location. Okay. I think, well, I hope that's right. I'm always afraid to say so now. All right. If generates red code. Okay. Let's add it to main. So else, another meta word. All right. And we'll do a make and a make repl. Okay, so colon foo. We want an if else thing. So this should be easy. 1 if 2 else 3 phi dot. Okay, 1 is true, so we expect this thing to print a2 and leave it on the stack. Well, so maybe I'll just do a pop. Okay, so if it's 1, which is true, we should print 2. If it's false, we'd print 3 and get rid of whatever that value was. All right, we expect to print 2. Good. Foo 0 if 2 else 3 phi dot pop. I expect to print 3. Good. Okay. I don't know if there's a nested version of this that will make sense. Yeah, let's try foo 1 if, so that should be true. And then let's do 0 if we'll push 10 else 20. phi, and then our else 30 phi print semi. Okay, so 1 is true, so I expect to take the first clause, which should give me an if, and the 0 says I should take the second clause, so I should get a 20 with this. Foo, 20. All right. Okay, so implement else clause on if statement. Okay. Well, that went nice and smooth. Okay, well, hope do while is fun. All right, but it's a good time for a break. So let's take a break, 3 or 4 minutes, and we'll come back and do the do while. And that'll wrap it up for control structures. All right, welcome back. So we want to do while or while do. I wonder if let's go see. Oh, I think it's in 68 version was where they did it. It's a reserved word. Oh, you had 4 while do on. Yeah, I think we can while do odd. Let's see if they demonstrate it. Yeah, so we're not going to do the I part, but yeah, I guess that's compatible with what they're doing. Okay, so it's very similar stuff. We're going to push the code address to the start. Well, that looks exactly like... No, it doesn't. Was that a repeat until does that? Push the code address to the start. Yeah, so it's really the same code as repeat for what it's worth. I think I'll break them out separately, but yeah, it's kind of the same. Jump if false back to the top. And this is just a jump back to the top. Oops. Jump if false after the while. Okay. Well, control tests again. Right. I'm still annoyed with these assertions being so bulky. Need to do some stack duplication for it to work. Yeah, I mean, well, it doesn't really know anything, right? So it just pushes the code address there, and it's fine. The test maybe, yeah, the order is different, but the activity's the same, maybe. Well, not even the order's not even different. It's just because it's the target and you haven't made any decisions yet. We're just branching back to it. Okay. At any rate, let's. Well, boy, I just want to make. Can I make a series of assertions? Like if I gave it a test secondary with I expect its contents to be this. Right. Let's... Oh, okay. Oh, yeah, for LF, we probably would have to do some flipping around. I think it ends up almost like being else. Well, no, you got to, instead of jumping, yeah, I guess you got to do jump in and or another conditional jump and stuff. It's an exercise for the reader, I guess, at this point. Okay, but anyway, what I want to do here is like I want to say assert secondary contents at offset 24 should be jump if false word address. Okay. And so this, well, there's similar ones throughout these control structure things. So let me make a macro. These jump, okay, I think it's down in here where we really care. So let's make a macro. Assert secondary contents. Offset should be I think this is address. Okay, this load address. I want one of these. Load the secondary, then offset it, and then do this. Okay. X0 plus offset. And then address. And maybe this is address too, because there's assertions are subtly different. Okay. All right. We load address with the secondary area. We load the contents of that address with an offset. We load the expected address, and that's our assert. Okay, so this, and it uses, well, let's say what it does. Looks up value at L test secondary area plus offset, compares to memory address. Okay. Excuse me just a minute. It'll be probably a 5-minute break. Sorry. Well, quicker break than I thought. Okay. Let's see. So this with offset and address. So this one is 0. 0 should be jump if false word address. Okay. I'm going to leave this for a moment. The test is repeat until generates right code. Let's make sure that runs. I moved this because we just were flipping too much. Okay, make unrecognized instruction mnemonic. I guess we'll take the 2 places. And maybe the number sign gives some problems too. I don't know. Nope. Repeat until, if else v. Okay, so that seems like a good change. This then is redundant. Let's go back up to the other one first, though. Search secondary contents. Jump if false word address. That was this. Offset 0. Okay. Now this, we're not doing exactly that. Okay, so that doesn't affect the rest of this. Okay. Now the assertion. That's different, but this one's not. So 40 should be jump if false word address. Keep doing that to myself. Offset 8 should be jump if false. Offset 32 should be jump word address. Okay, well, that test isn't even real yet. Okay. But this should make and pass. Control this. Good. All right. Use this macro in tests. All right, we'll take one step better, I guess. Okay. Iffy, that's fine. But all these other ones, we should make macros for the other kinds of tests too. Oh, did I not duplicate this? So this is do while odd generates right code. Yeah, we may do that. Because there's some that look a little differently. Okay. Same starting thing. We're going to write something before it. That's fine. Then we're going to do a while. And then there's an expression. So we need another value there is 2. and then do here, and then another value 3 for the body, and then odd, and then 4. Okay. So that's pretty good. Okay. And then the assertions. All right. First thing we expect is, we expect 1 and then 2 right away. Okay. So L-test secondary area move x0, 0 should be 1. Yep. And let's make a macro for this. And I think this is a constant, maybe. Offset 0 value should be 1. Okay. Okay, load this off. This is the offset. This is the value. And just about everybody should be able to benefit from this. Okay, so the first value should be 1. All right, now the second one should be 2 at offset 8. Okay, so the 1 is before the while, 2 is the expression, which is the target. Okay. And then 3 is jump if false. Okay, so this should be 16. Jump if false word address, yeah. And then it should be followed by the address of the end loop. Well, 0, 8, 16, 24, 32, 40, 48, 56. Okay. Secondary contents 16. Well, I think that's this one, isn't it? Oh no, it's that plus 48. Now, is this, you could add a second offset. Yeah, so this, I think, is this going to be the right one? Address secondary contents. Where have I tucked this thing? Okay, offset x0 offset load address x1 address. I think this is offset 2 equals 0 to what you're saying. All right, and then x1 equals x1 plus offset 2. Okay. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this code in, assert set contents address. And I'm just going to copy this Okay, so load address x0 that, the offset, x1 gets the address, add x1 gets the offset. Okay, so this 24 should be L test secondary area plus 56. Yeah, I don't care really, right? I mean, it's the test is paying for it, and we can be a little generous there. Okay, so the contents at slot 24 should be L test secondary area plus 56. Okay, that's the jump if false. Okay, then the body 1, 2, 3. So that's one of these again. Three at 32. Okay, then a jump at 40. Jump word address. And then this should be start. Well, that should be 8 because we have a value before our start label. Okay, so the contents. This plus 8. That's address 48. Okay. Jumps back to start. And then our 4. And we'll take our control stack as it was. Okay, well I think that's definitely better. I mean, I can see the offsets 0, 8, 16, 24, 32, 40, 48, 56. They all increase by 8 like they're supposed to. And we're looking for jump at forward address or secondary area plus 56. I almost could make a separate assertion for that. But yeah, this is definitely where we should be going. At least it's an improvement. All right. However, this test will fail. We don't even have do while not yet. We'll say more. Okay, and then globals. Okay. This will fail. Well, not like that. Move x1 value. Where was that? Instantiation 3.2 control tests. Oh, did I leave out a backslash maybe? value offset. Let's go check that other one too. Offset address, offset 2, got backslashes and all of them. Okay, good. Oh. No infinite loops, just failures. Okay. X0, we're expecting an address. We got 3, 4, 3. Okay, well. All right, what's while going to do? It's the same as repeat, we said. So let's just copy the code. I'm duplicating here because I don't think there's anything conceptually that forces repeat and while to have the same beginning, you know? I mean, this is the way we chose to implement our while and our repeat. They happen to be the same, but I don't think it's inherently the same. If I can say it like that. Okay. Okay. Now do generate jump if false. Yeah, I think it is accidental duplication. I mean, there's something about it. And, you know, if I had, let's say we had a dozen control structures and 4 or 5 of them did that same thing, then I might define it as being, you know, push current word or something. You know, it wouldn't be wrong to have a common routine to do it. But on the other hand, you know, it would still be a decision whether I was calling that common routine or not. And, you know, in this case, we just happen to be calling the common routine, except it's not really a pull-out routine, but it just happens to be duplicated. So, yeah, I'll live with it that way. All right, generate a jump, push an address, generate a -1. Well, that sounded a lot like this. Generate a jump. Actually, it sounds exactly like that. Generate a -1. Well, no, it doesn't. It sounds like kind of part of that. Generate the jump. Yes, that's fine. Push the code address on the stack location. That's fine. But this piece we don't need because that was the twisty if-else thing. All right, generate a placeholder address. That seems like that. Okay, so we capture the address of this placeholder. Maybe this placeholder address to patch. Okay, load jump word address and store it. Control pop, capture the address and push it. And then generate the placeholder. Yeah, I think that's good. And then this, generate the jump. Okay, well that's... Wait, that should be a jump if false, right? Yeah. Okay, so this one gets a jump. Then we got to do a control pop. And that's kind of like... Well, no, it's not. Okay. So we're catching the do and the start. Pop, no, what's that other address? Oh, start. Jump if false is the first one. Start address is the second one. Okay. Generate the start. Oh, we generate the jump. Okay, now we generate the start address. Yeah. That's this. Well, no. Generate the jump. I guess we're just writing the start address. And we want to go back to the start. X1's the start. And then patch this address into jump if false. Well, that's this kind of thing. Where's the end loop address? No, patch current. Wait. Okay, so the start is on the bottom, and then the jump if false address we want to patch to is the current address. Okay, so I think I've said this wrong. Store secondary space. Oh no, that's the current address. Okay. Into X0 is the jump if false address. Yeah. Okay. Yeah, odd needs to patch. Okay, it generates this. Okay, and then it pushes the popped start address, which was the second one down, and then it patches the end loop. Okay. Okay, I think I'm okay. All right, let's see if we are. Control. Boom. No. Segmentation fault. All right, let's just run control tests. And we'll just see if we can quickly see where it's blowing up. In odd, the store into X0. Bad address, 0. All right. If we while pushes, do pushes. So this should get 2 valid addresses. Why did it get a 0 for X0? X0 store sec. Let's make sure this doesn't use X1, X0. No. Maybe we're pushing the wrong thing. X0, control pop, X0, that's do. Is that supposed to be a push? Do generates the jump if false, gets the code address. 6.3 should put the address in secondary space. Well, this writes jump if false. This writes the placeholder. But I think this is supposed to be a push, right? We only pushed once. We popped twice. I think I've just I think he should be secondary space. He should be this. Is the address to patch. Because, yeah, you definitely need 2 pushes to make over the 2 pops. And secondary space is the location of the next word, which is the -1 that should get patched. Okay. Well, sorry. Quit, make. Oh, I'm bumping my control list. Okay. Woo. Ava A. Jackson, welcome back. Oh, welcome the first time. Okay. We're doing a programming language implementation. It's there's a language called Forth that is very stack-based and was kind of used a lot in the 70s into 80s, maybe. I don't know if it's much used after that. It got its start being a control language for radio telescopes, and then I know it was used for editors and other things. We're implementing a compiler and interpreter for it in assembly language, and we've just finished implementing a while loop. And I think with that, that kind of finishes the control structures. We need to make sure the thing works in the manual test mode, but the TDD we've done, test driven development we've done, we've tested these all kinds of things along the way. So feeling pretty confident we're close on that. I had to make something up using it. Okay, but tests are passing. So let's check this in as it is. Implement do while do odd. Okay. And come on. There we go. All right, so let's go in the REPL. Now we're going to have to do something to make this work. All right, so we'll define a routine. Oh, well, no, we have to implement main first. Okay, so this. While. Do. And odd. Okay, so this kind of activates the definitions for these 3 words so we can run our test. Make REPL. Okay, now we're going to do a run. Yeah, well, it's a little different than usually. I've been doing like Swift implementations for the most part, but I got on a tear to go after this particular interpreter style, and to try the assembly language stuff. Okay, all right. So we have to make sure. Yeah, we're about to write an infinite loop. Okay, so I'm going to try and print 54321 or 5432110. Okay, so while I guess I want to dupe and compare to 0. Do I have a greater than 0? Main. I think we might just have a less than 0. Yeah. Okay, let's do this backwards. Okay, we'll duplicate that 5. No, is that what we want? Okay, well, let's duplicate it. Well, the value at the top of the stack is greater than 0. What we want to do is print the value at the top of the stack. It was duplicated, so we still have 1. And then decrement that value 1 minus. Yeah, we have greater than. That's progress. Okay, so we will duplicate the 5, test for greater than 0. It should be. Print it, subtract 1, and then I believe we'll go back to the top of the loop. And, well, we should probably pop at the end because we left 1 on there. But this duplicates it and consumes it, so we still have something on there. We should have a 4, go back around, duplicate the 4, and check for 0, and so on. Okay. And then if we say foo, we should get 5, 4, 3, 2, 1. Haha. Okay. Is it web coding? No, it's assembly language coding. So kind of, you know, it's very, yeah, it's nothing to do with the web. It's just a command line programming language. It's not written in anything like a web language. JavaScript would be, 3 levels up the stack from here, probably. Well, 2 maybe. Yeah, it's written in C, I think, at least usually. Okay. But anyway, I think our repeat loop is working. So let's capture that. So we implemented while do odd loop. Okay. Well, I didn't think we'd get this far till tomorrow. But I have some stuff we can look at. It's just the next stage. All right. So we've implemented those. The next thing I want to worry about is variables, and I probably should have drawn a picture, but I'm imagining that you will say variable name. Variable is one of these meta words that just always runs. It's going to create a dictionary entry for whatever that variable name is, and it's going to put a routine called load address. I'm not sure we need step 2, but my thought was, so we have our headers, like the link and the name pointer, and then the actual routine to call, and then it gets into the body. Well, I want our body, if we have to, the first word will point to the next word, so load address can find it. I think load address can take the address of the body, or it already gets the address of the body, and it'll somehow load that address, which will give us the address of the following word, which is going to be a 0 initialized variable. And so when you call load address, it should load the first word to the data stack. So it should load the address of the variable, not the contents, but the address. And then if you call at, that loads the contents of it. So yeah, name at will get you the contents of that cell. So if you did variable name and then you said name at, it should print 0 because it's initialized to 0. Now the opposite is the store, and store pops the 2 addresses, and the value B goes into the address pointed to by A. So if you said name 7 bang, it would pop the name and the 7. Name would have brought the address up. The 7 would be the top of the stack. Oh, I got that backwards, don't I? Should be, let's swap that. Store the value A into the address pointed to by B. Okay, go back up. All right, so if I push name and then 7, I want to store 7 into name. Okay. And that gives us the bare minimum for variables. Like I said, I think we can drop step 2 and we'll just know the address. They call this a passive word or a passive secondary. It's usually our secondaries have lists of functions to call, and this doesn't have that. It just has raw data. Okay, I think the same mechanism is basically going to work for arrays. All right, so you'll say array 9 name and then the size, and then we'll do the same as before, then allocate the header with the load address, and then I don't think we'll need step 2, but then allocate the number of words that you asked for, the size, and load address is the same load address as before. It's going to load the pointer to the array on the data stack. So kind of like C does. And then I've defined pop AB. Well, I think it's really A plus 8 times B because name offset. Yeah, I think it's going to be 8 times B in both cases. Okay, because we have 8-byte words, so we need to offset. You know, if B is the A is the array, like if you did A to the name array name, and then 2, and you said plus at, we're going to get the value at the start of the array plus 8 times 2 is 16. Will give us, you know, the address at the third slot, basically 0, 8, 16, and then take that value out of that cell and load it onto the stack, and then plus bang is a store, but it's got the stuff built in, and I got them backwards again, didn't I? Ugh. Okay, so B should be the address, the name. And then A should be the offset. And this one, store the value A into the address pointed to by C plus 8B. Okay. Yeah, so I added a word for variable. It'll read the name. It'll be just like the definition one, the colon one. It says colon foo. Then colon knows to read the next word as the name, and that's going to be the same kind of thing that goes on. We have to implement it kind of like that. Yeah, so the value on the stack is going to be the address. So if you do addresses, like if you do variables, you're going to do pointer arithmetic, basically. I mean, you're going to manage pointers. I mean, the at sort of hints at that. But yeah, I think that'll give us a mechanism to do that. So the name will consistently load the address on the stack, and then you'll use these operators to get through to it. I don't expect you to use a lot of variables. I mean, for the most part, like all the computation stuff, you're typically going to do on the stack, but you have stuff that does need a home, and it's very inconvenient to put it, 6 levels down on the stack or something. So I think the scheme will hang together. And then the last thing, we won't get to this in the next 6.5 minutes, but I think I also have a scheme for strings that's kind of related. If you do quote string, that's something the interpreter or the compiler is going to, treat similarly. It's going to create a string in our free space. There's not much difference. It'll have to create the string, adjust the offsets to make sure it's on an even boundary for the next thing that happens, but it'll create the string and then push the address on the stack. Okay, and we'll make strings be immutable, and I think I'm just defining a handful of methods for it for now, but print $, is going to take the address that's pushed on the stack and call that as a string to print. And then split $, is going to be the thing that does the work for the most part. It's going to take the string, and then it's going to take that address, points to a string, just like C, that number plus 1 will get you to the rest of the string. And so it'll push the pointer to the rest of the string, and then it'll push the character as just a normal integer on top. And you can manipulate it however you need to. So I debated calling this head because it's kind of printing the head character or splitting off the head character. But I don't know. You got to pick something. All right. So I think this will let you write a loop where you're just sort of working your way through the string until you hit a 0, and then you'll, do whatever you do when you hit the end of a string. Okay. And then the last thing I want to add is make dollar, and make dollar is basically array to string. Okay. So you'll create an array, you'll fill it up with numbers that correspond to characters, and then make dollar will, allocate space in the free space for that and convert those characters. Well, it'll really just write them into the next free space until it gets to the end, and then go. So, I think these three proposals together as sort of the way to work with things will give us variables, arrays, and strings. Now, I don't know about array of strings. I guess you could probably do that, right? I mean, you're just going to say push the string and then store that in the address in the array as a string. You would be able to do kind of a primitive pointer stuff. I don't know if you would be able to do full nested kind of stuff, but I guess you might be able to. So I think it'll generalize to array of strings without any work. You might have to manipulate them a little funny. You'll have to, instead of just saying print dollar, you'd have to do like at print dollar or something, or bang at or something. But it'll go. All right, so let's go back to variables. All right. And let's look at start 2D, because I think the clue is there. Start 2D interpreter. Oh, let's see. Years of experience. Yeah, I don't know, 30 something. Been at it a long while. I'm not sure I can give you much advice on game development or web development. I mean, I do basic website stuff and have done that from kind of the beginning of that, but I really don't think I can get you anywhere from where we're working here. I'm sorry. But good luck. I mean, you're welcome to hang around, but I'm pretty sure this is not going to be much of a good starting point for you. If you're doing web, most people seem to be working in, well, a lot seem to be working in JavaScript there, frankly. I don't know if that's changing. And there's a lot of different libraries for JavaScript that also seem to change all the time. So it's kind of hard for me to keep up with what goes on in the JavaScript world because I don't really use it for anything other than the barest minimum trivial kind of stuff. So yeah, I'm not sure what there, but game stuff, I mean, most people I know doing that, a lot of it's been in C or C++. Python gets some use. Maybe JavaScript for just kind of pure web games, but yeah. React for JavaScript, that seems reasonable enough. But I'm sure there's channels where people are doing stuff that's more. No, I don't use either one, so sorry there. And as you can tell, I'm not doing a lot of graphical stuff, so I can't make use of your professional services either. So, oh well, sorry. Yeah, you can follow on here if you want, but like I said, I doubt you'll get much you're looking for if you're thinking about games and web stuff. All right, star 2D. Yeah, so when you call star 2D, and this is called by the interpreter, it gets x0 pointing to the secondary list. So that tells me we don't need that. We don't need this. So I was going to put the first word being a word pointing to the second word and then have it work from there. But we already get the pointer to the first word, so there's no point in doing that. Same thing here. I don't think I did that there. No. Okay. Right. So I think what we could do, let's do like we did before. We tested the load, the assembly language routine that interprets it. Let's make sure that's doing what we want. And then from there, we'll work on generating the code to actually interpret variable name. So I'm going to interpret the load address routine is just going to be a load the memory kind of thing. And then we'll come back and define this stuff up at the language level. Variable's the keyword, name's the variable part. And same thing here. Okay. And load address, I guess maybe interpreter is the right place for that too. So let's, oh man. Okay, interpreter tests. Okay. And we're going to, well, we're just going to do a test for load address. Returns address of secondary. All right, and test end. So somewhere in the middle here, well, we got a range. I think my keyboard slid over a little bit and I'm just hitting a lot of equal signs today. Okay, well, the act is be a load address. Now, where should that, what should he be doing? I guess you give him X0. Is he loading the address? Maybe that's not the right name for it. But let's put something in. Yeah, maybe that's it. It is April Fool's. Maybe somebody swapped my keyboard around a little. No, I think I had too much junk I put on my left, and I had to slide the keyboard to the right, and instead of delete, I hit it equals all the time. All right, let's just put something in the address. Well, let's allocate something, I guess. And text dot align to. Okay, so if I allocate an address, L test address, and I'll just put anything in there. Okay. Load address X0 gets L test address. It's like an identity function. I guess at the end, X0 should be returned. Kind of does nothing. Load address L test address and assert equal. Okay, this is a weird case. How fun. Interpreter. Okay, I'm going to make load address, and I'm going to move 77 to X1, X0, and return. Okay. Well, I think I didn't realize it was quite so late. If you'll indulge me for 1 or 2 more minutes, I think we'll quickly make this fail by throwing junk into X0, and then we'll just do nothing and it'll pass if I call the test. Okay. Okay, and make. Oh, I have to do some other. Okay, this will take a little tiny bit of thinking, I think. um, it doesn't like doing load address for data segment stuff, I think. So that'll be a bigger thing to work around. So we'll pick up there tomorrow, 2 to 4:30 Eastern Time or 6 to 8:30 p.m. UTC. I'm pretty excited. We got the control structures. Yeah, I'm not sure what the address is, but I think ADRP is our breakdown for load address that's trying to get the page, and I think maybe it can't get that at runtime. I don't know, but we're already late, so I'm not going to try and debug it. But anyway, 2 to 4:30 Eastern Time, 6 to 8:30 p.m. UTC. Yeah, good point. Thanks for joining, and I'll see you tomorrow some other time. Take care. Good night.